consider this problem statement here. So here it says that let a, b, c be three non-zero real numbers such that this given equation, that is square root of 3a times cosine of x plus 2 times b times sine of x, this is equal to c, and it says that clearly that x lies in the closed interval of minus pi by 2 to pi by 2. Fine. So it has two distinct real roots, that is alpha and beta, with the sum of this alpha and beta as pi over 3. So in that case we need to compute the value of this a over b, right? Now let's see how can we solve this one. So here, before I proceed to this one, writing this alpha and beta is little difficult for me, so I'll consider alpha as p and my this beta as, just for my notational convenience, nothing else, no other reason. Now here, this is the given equation, right? The constant is given, I'll be using the constant later. So here we have in this section, I'll be taking my equation, that is the given equation as it is. So here, if alpha and beta are the roots of this, definitely that is p and q, which I've considered here alpha beta, that should satisfy this one. So instead of x, I'll be substituting p here once, and the next time I'll substitute q over here, the next time q. Now I'll perform the subtraction operation. If I subtract this one, on subtraction I'll be getting here square root of 3a, and this will be cos p, sorry, this will be cos p minus cosine of q, first term, right? Second term would be 2b is common factor here, and this would be sine p minus sine q, and c minus c would turn out to 0, right? So this part is done. Now I will proceed ahead. So finally this is the equation that we have got. So now let us proceed with this. Now from this one, I will apply the identity, that is cos c minus cosine of c minus cosine of d, or cos a minus cos b, and here sine a and then minus sine b, right? So we'll be applying that identity. So now copy this as it is first of all, and then apply the identity. So on applying the identity, I would get minus 2 times sine of, this would be p plus q over 2, then sine of this p minus q over 2, p minus q over 2. Next, then the next term I'll be expanding, so that is sine c minus sine of d. So this will be, the structure will remain the same, I'll take this one, and here it will be 2 times cosine of p plus q by over 2, and this would be sine of p minus q over 2, and this will be equal to 0. Now a very important point that is mentioned here. So if you observe, these two are distinct real roots, right? Since p and q are two distinct real roots, that's mentioned, right? So from this we can clearly write that it clearly implies that p and q are not equal, p is not equal to q, and this further implies that p minus q is not equal to 0, and if I divide 2 on both the sides, that is p minus q over 2, that is not equal to 0, right? That means this quantity p minus q is not equal to 0, and this further implies that if you take sine of p minus q over 2, this is even not equal to 0. So if you observe, this sine of p minus q over 2, and here also this is the common factor, so I can take this common factor and divide it both the sides, right? So this is something that I am going to do, and how I am able to do it, because of this particular reason that is mentioned in the problem statement as well, that these two, right, roots p and q, which I have taken as alpha and beta, is not equal, they are not equal roots. Now proceeding further, so definitely I can take the sine of p minus q over 2 as the common factor, and I can just cancel out these terms, right? Similarly, this 2, one of the two can be taken out, right, and can be divided on both the sides. So let's eliminate this, right? So we can eliminate the 2 as well, correct? So we can just skip that part. We can just take this 2 and divide on both the sides. That is totally fine. Now I'll make my final substitutions, that is p plus q over 2. Now this is given already. If alpha, this is given to us that alpha, this is alpha plus beta is this, right? And instead of alpha and beta, I've taken p and q. So from this we can also say, since this is p and this is q, so this is pi over 3, right? So definitely we can say that if I divide this by 2, if I divide this by 2, I'll be getting pi over 6, pi over 6. Now I'll take this one and proceed towards the next step. Now from this I can write this one as negative square root of 3 times a, and this would be sine pi over 6. This would be sine pi over 6. Similarly on the other side, this 2 is already eliminated because I have taken as the common factor, and this would be again pi by 6 instead of this, pi over 6. Let me remove the outer parenthesis, and these values are something that we are already aware of. So from this we can clearly observe that a over b, a divided by b, that would be equal to 2 here, right? On substituting the standard values of sine pi over 6 and cosine pi over 6, we can clearly observe that a would be equal to 2 times of b, because this square root of 3 is also something that is going to get cancelled out. So finally 2 is the answer, right, for this one. So for this given problem statement, a over b is equal to 2, right? If you have any confusion, just plug in the values of sine pi over 6 and cosine pi over 6, resolve this equation, you will get a over b as 2. So 2 is the answer for this one.